Number 2 on the short answer says graph y is greater than 2x squared minus 4x plus 3. Let's look at this inequality here. The greater than means we're shading above because it's greater than. And since it doesn't have the or equal to, that means we're going to have a dashed curve here. Now, in order for us to graph this, we need to have some key points. So let's find the vertex to start. In order to find the vertex, you got to use the axis of symmetry formula to find the x-coordinate. So we got x equals negative b over 2 times a. Well, b in this case is negative 4, so we have really negative 4 over 2 times our a value, which is 2. So we get positive 4 over 4, which just gives us 1. So our vertex, we've got a point at positive 1 on our x. To find our y value, we're going to plug that in. So we're going to treat it like a regular inequality. So you got y equals 2 times 1 squared minus 4 times 1 plus 3. So we got 2 minus 4 plus 3 giving us positive 1. So our point ends up being at 1, 1. So let's plot that on our graph here. Vertex at 1, 1. Another thing we know, we can find the y-intercept, which is just that 3. So we go over to the y-axis, put a point at 3, and folks, really this is enough for us to get a pretty good looking graph, because remember our vertex, which I said we used, or we found the axis of symmetry and used that to find the vertex. So we got that line going through our axis of symmetry, which acts as a mirror. So anything that's not on the mirror has a mirror image of it. This gives us enough points to just kind of come up with a reasonably good graph. Now we can start connecting our points. So this is our vertex, it's our lowest point. We got to have a dashed curve. So it's going to look something like this. It's not perfect, but for what we need, it's going to be good enough. Now when it says shade above, what I always look at is shade above your vertex. So if you're shading above your vertex or below your vertex, that just means shade immediately above it or immediately below it. So if we're shading above our vertex here, we're going to be shading inside of here. And there you have it. That's where all of our solutions are. Now if you want to go through and test out a point, we can test out a point, say, like right here. That's a point that would work in there. Go through, plug in y equals 4, x equals 1. It'll all work out.